Hey everyone, Grant here for the Flame Learning channel. With the release of Flame 2018, we have started to introduce 32-bit float support throughout the Flame products. The main reason for this is to provide a 32-bit float processing pipeline which includes support for 32-bit data parsers. So this allows you to import 32-bit OpenEXRs, which can be cached as well as processed at 32-bit through specific nodes. And finally, as you output an archive, you can also retain the full 32-bit float quality. This ultimately improves image precision and processing using various high-quality media. I mentioned data parsers, and this includes motion vectors, UVs, world position, Z-depth and more. So let's see how the 32-bit float support currently works in Flame 2018. If you would like to follow along, please click the link in the YouTube description to download the media. Alternatively, if you're watching the podcast version of this video, then type the displayed link in your favorite web browser. Now, when you create a new project, you now have the option to set the project defaults to 32-bit. This means wherever possible, certain tools will default to 32-bit, and all your intermediates will be rendered as 32-bit float OpenEXRs. Remember that this is just a default setting, and you can always work with multiple resolutions in a project. Now let's go into Flame. Starting in the Media Hub, navigate to the download directory containing media with different bit depths. This camera footage is 10-bit, and these images are 8-bit. There are also some 32-bit OpenEXRs to build the example. Now these OpenEXRs can be CGI or data parsers of various sorts. In previous versions of Flame, these 32-bit OpenEXRs would have been downscaled to 16-bit. This is still the case for Lustre. If you import any 32-bit media into Lustre, it will also downscale from 32-bit to 16-bit to work within the application. Now when you select a 32-bit OpenEXR in the Flame 2018 products, like this STMap datapass for example, call up the preview window and Flame will display its resolution as 32-bit float point. When you drag it into the media panel and alt-click it for its properties, the information box will state 32-bit as well. You simply treat the media as you normally would. Now import the remainder of the media into the media panel. Now let's switch to Batch and discuss some of the tools that support 32-bit float point. Firstly, I recommend looking at the What's New documentation to see the current list of which nodes are 32-bit capable and which nodes are limited to 16-bit. It is possible to load a 32-bit clip into a 16-bit processing node, but the internal processing will only be at 16-bit. This is how we've made it possible to still work with the media, even using 16-bit tools. For example, if you load a 32-bit image into Batch Paint, the Batch Paint node will tell you it is running at 32-bit float, and the output will be as such. But if you use a tool in Batch that only processes at 16-bit, like a blur node for example, adapters and indications will be placed on the incoming node connections to point out the downscale from 32-bit to 16-bit. This helps you to always know how your flow graph is processing the information. So to give you a heads up, tools like Action, Batch Paint, 2D Transform, Flip, Resize, and even Matchbox shaders are now 32-bit capable. Let's start looking at an example of how 32-bit float can be beneficial. Firstly, we'll tackle typical lens distortion. Here I have some GoPro media which is shot with a wide-angle lens, resulting in lens distortion or a barrel look. There are a lot of techniques to reduce lens distortion, and one of them is to use the STMap or lens distortion map to remove the lens distortion. They are typically 32-bit images, and this one was generated using Mocha Pro version 5. To remove the lens distortion, go to the Batch node bin and drag out a matchbox node. In the file browser, locate the UV Warp 32 node. This matchbox GLSL shader is 32-bit, and it is possible for third-party coders to upgrade their existing matchbox shaders to 32-bit as well. Feed the 32-bit OpenEXR into input 1, and the 10-bit GoPro media into the input 2. When you look at the result, the lens distortion has been removed. You can toggle between F2 and F4 to see the before and after. This is using 32-bit float point precision as opposed to 16-bit precision compared to previous versions of Flame. To see the difference, you can load the 16-bit OpenEXR of the same ST map and recreate this flow graph using the same GoPro media. Once you've set it up, go to a 2-up view with the batch schematic on the left and the result view on the right. Now zoom in tight into one of the windows. When you toggle between the matchbox nodes, the pixel precision is much smoother in the 32-bit output compared to the 16-bit output. So all the 32-bit enabled nodes will take advantage of this higher quality processing and image precision. Now there are a range of compositing tasks that may require a 32-bit float pipeline. For example, you can be supplied with 3D data, such as render parsers and 3D geometry, and you can use the 32-bit capable nodes to give you the best float point precision when it comes to processing and image quality. In part 2 of 32-bit float support, we'll take a look at how action works within the 32-bit float environment. Be sure to check out the other features, workflows, and updates to the Flame 2018 products. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Learning channel for future videos.